Software Wala and I'm in a one student at Ham School Islamic campus. So today I'm here with the new Maya. So our today's my topic is why do leaves change color in the fall? So let's start our today's Maya. First of all, call the Maya for some questions. Okay.
Hi, what's up?
So my first question from you is what happens to leaf during the fall season? So please give me a very interesting answer on this topic. So let's start your answer, Maya.
I'm not sure I caught what you said clearly. Could you repeat your question about what happens to life during the fall season? Got it. You want to know what happens to leaves in the fall, right? It's actually a pretty amazing process. So most people think it's just because of colder temperatures, but it's more about daylight. As days get shorter in fall, trees get the signal that winter's coming, basically, a signal that it's time to conserve energy. Leaves are basically these incredible little solar panels constantly churning out sugar through photosynthesis. But to do that, they need sunlight, water, and chlorophyll, that green pigment we associate with leaves. Winter doesn't exactly offer ideal photosynthesis conditions, so trees start to shut down leaf production because it's simply too expensive to maintain. Here's where it gets interesting. Chlorophyll is actually pretty valuable to the tree. It's full of nitrogen. So before letting leaves go, the tree reclaims that nitrogen by breaking down the chlorophyll. That's when all the other pigments in the leaves start to show through, yellows and oranges from carotenoids, and reds and purples from anthocyanins. We've actually been seeing all of those pigments in the leaves all along. They're masked by the chlorophyll when it's present in large amounts. When enough of the chlorophyll breaks down, we can see those colors. That's why forests explode into such vibrant hues in the fall. It's basically the tree recycling its nutrients instead of wasting them on something that isn't going to make more sugar. Eventually, a layer called the abscission layer forms at the base of the leaf stem. This is like the tree gently severing ties, cutting off water and nutrient supply. This layer creates a weak spot where the leaf eventually breaks away and floats to the ground. And then the leaves create this colorful carpet that does something really cool for the soil. They decompose and return nutrients back into the earth that the tree will use next spring. What do you think about that as a way to understand what happens in the fall? Are you interested in hearing more about the science of pigments or the chemical reactions involved in fall colors?
Okay, that's really great. So my next question from you: why are the leaves green in summer but not fall? So what is chlorophyll and why is it important? So please give me very interesting answer on this topic. So let's start your answer, Maya.
Okay, so we were just talking about chlorophyll, and you're asking why leaves are green in the summer, but that green disappears in the fall. It all comes down to this pigment, chlorophyll, and its role in photosynthesis. Chlorophyll isn't just one thing, actually. It's several different types. Chlorophyll A, chlorophyll B, even chlorophyll C and D. But most land plants rely on chlorophyll A and B. These molecules are super efficient at absorbing light energy from the sun. However, they absorb the red and blue light, but they aren't good at absorbing green wavelengths. So green wavelengths are reflected, which is why we see green colors. So in summer, when the plants need to capture energy from the sun as much as possible for photosynthesis, chlorophyll production gets ramped up and it becomes the dominant pigment in leaves, masking the yellow, red, and orange colors underneath. The chemistry behind chlorophyll is actually pretty cool too. It has this magnesium atom at its center that's key to capturing light energy and getting photosynthesis going. The important thing about chlorophyll is that's what makes all the oxygen in the atmosphere that we humans need to breathe. Pretty wild to think about, right? Without chlorophyll, plants couldn't make their own food, and we wouldn't have the atmosphere we do. Plants actually need nitrogen to make chlorophyll, so that's why the trees reclaim it during fall months. Does that make sense?
That's really great. So, Maya, my next question from you is what colors appear when chlorophyll disappear and what are carotenoids? So, please give me very interesting answer on this topic. So, let's start the answer.
Okay. I think you're asking about pests and holes in leaves. What kind of pests cause damage to crops and what kinds of holes they make in leaves? That's a great question because there's actually a whole world of them. Some common ones include caterpillars. These can eat huge holes and leave behind bits of leaf while they work their way through it. And then you have things like aphids. These tiny sap suckers don't make big holes, but they cause leaves to get distorted and mottled or develop like yellowish spots that can weaken the plant. Leaf miners are sneaky ones. They literally tunnel through the leaf tissue, creating winding paths inside. Other pests, like beetles, might chew more regular circular holes. Some can do real damage too. The Colorado potato beetle, for example, can decimate potato plants in a hurry. Different pests cause different kinds of damage. So, experienced farmers can sometimes identify the problem just by looking at the pattern of holes on the leaves. The more specific you can be about what plant is being damaged, the more I can explain specifics of different pests too. Have you seen anything like this with particular plants? Are you still there? Just checking in.
Okay, so my next question from you is Maya, what are economics and why do some leaves turn red while turn other yellow twinkles? So let's start your answer, Maya.
Okay, so you're jumping from plants to economics. That's quite a switch. Let's tackle economics first. Essentially, economics is how societies deal with the scarcity of resources. Think of it as studying how people make choices when there isn't enough of everything we want, like money, time, natural resources, everything. It deals with production, distribution, consumption, who makes things, how they get to us, and who buys them. It also looks at markets, trade, money, unemployment, and economic growth. But at its core, it's about making decisions and how those impact economies. As for why some leaves turn red while others turn yellow, it comes down to the specific pigments present in each tree. Remember how chlorophyll breaks down in the fall, revealing other pigments? Some trees have a lot of carotenoids, which show up as yellow and orange. Other trees produce anthocyanins, those create the red and purple colors. Anthocyanins are actually created specifically in the fall when sugars get trapped in the leaves and interact with sunlight. So trees that produce anthocyanins will turn red, while those with more carotenoids turn yellow. Different species are just genetically predisposed to different pigment mixes. Pretty cool how something basic like leaf color tells us about a tree's biochemistry, right?
Okay, that's really great. So my next question from you is Maya, why does not all trees change color the same way? So please give me answer on this topic. So let's start your answer.
That's a really observant question. It's true. Some trees go bright red, others get that classic golden yellow, and some barely change at all. The biggest reason is those pigments we talked about, anthocyanins and carotenoids, and how much of each tree can produce. Trees like maples, oaks, and sweet gums tend to make a lot of anthocyanins, so you get the vibrant reds and purples. Trees like birch, aspen, and beech primarily have carotenoids, so they turn yellow and gold. But it's not just that. Some tree species make very little anthocyanin at all, like pines and sorry, I'm not following. Could you say that again? Right. Continuing about like why trees don't change color the same way. Another factor is the environment. Sunny days and cool nights promote anthocyanin production. So areas with those conditions tend to have redder fall foliage. Sugar levels also play a role. High sugar concentrations in the leaves encourage anthocyanin production too. Some trees just naturally have different amounts of sugar stored in their leaves. Soil conditions can play a part as well. The minerals in the soil affect the tree's health and can influence pigment production. So it's a mix of the tree's genetics, the weather conditions, and what's happening in the soil that determines exactly how a tree changes color in the fall. Do you find that interesting how so many factors come together?
Okay, so Maya, my next question from you is
Still
how
there?
does sunlight affect leaf color? Please give me answer on this topic. So let's start.
Ah, that's a perfect question. Sunlight plays a huge role in leaf color change. It's actually two parts, the amount of sunlight and the type of light. As the days get shorter in fall, trees get less sunlight overall, which kicks off the whole process of breaking down chlorophyll and showing other pigments. But sunlight also triggers anthocyanin production. When sugar builds up in leaves, bright sunlight seems to encourage the creation of those red and purple pigments. So the more sun, the redder some leaves get, which is why especially sunny fall days can really intensify those colors. Less sunlight means the chlorophyll fades first, bringing out the yellows and oranges already present. It's like sunlight is both a signal that fall is coming and then also helps create the fall colors we see. Does that make sense?
Yes, that's really great. So my next question from you is does temperature influence fall colors? Please give me answer on this question. So let's start.
Yeah, temperature has a huge impact. The sweet spot for really vibrant fall colors is actually cool, but not freezing temperatures. You need cool temperatures to trap sugars inside the leaves, which helps create those bright red pigments. Here's how it works. When temperatures drop at night but stay above freezing, the sugars produced during photosynthesis get stuck inside the leaves because the veins start to close up. That buildup of sugar triggers the creation of anthocyanins, which make the leaves red and purple. Mild temperatures during the day also help maintain those sugars in the leaves. But here's where it gets complicated. If it stays too warm, the sugars move out and you get less vibrant reds. Really cold temperatures or a hard frost can actually kill the leaves before they reach their peak color. That's why you'll often see the most spectacular fall colors after a period of cool, sunny days and chilly nights. Did you know weather patterns can actually predict whether we'll have a colorful fall foliage season?
Okay, so Maya, my next
Just checking,
question
are you
from
still
you is
following along
why
or should
do
we move on to
Maya, why do leaves fall after changing color? Please give me answer on this topic. So let's start your answer.
Great question. So this is the color change is actually part of the process of the leaves falling off. They're connected. When the tree starts breaking down chlorophyll and making less sugars, it also starts forming this layer called the abscission layer at the base of the leaf stem. Think of it like the tree is prepping to detach the leaf, kind of like when you break off a branch that needs trimming. Once that abscission layer develops, it cuts off the water and nutrient supply to the leaf, so it stops getting what it needs to survive. The leaf is already in survival mode because it's been reclaiming its nutrients anyway. Once that connection is completely cut, a breeze or even just gravity will cause the leaf to fall to the ground. So the color change, the nutrient reclamation, and the abscission layer all work together. It's like the tree preparing for winter and going into conservation mode. Pretty clever design by nature, right?
Okay, so
Everything all
Maya,
right?
my next
Just
question
making
from
sure
you
you're
is
still with me.
how does leaf color change help trees survive winter? Please give me answer on this topic. So let's start with answer, Maya.
That's such a smart question. So the leaf color change isn't directly about helping the tree survive the winter. It's actually about preparing for it. Remember how the tree reclaims all those valuable nutrients from the leaves before they fall off? Especially things like nitrogen and phosphorus that are essential for growth but hard to come by in winter. By breaking down chlorophyll and other components in the leaves, the tree can store those nutrients in its branches and roots, ready to use for new growth in the spring. Dropping the leaves also prevents damage from snow and ice buildup in winter, which could snap branches. It's basically shedding weight that's no longer useful. Basically, losing leaves saves the tree water during dry winter months when frozen ground restricts water uptake, preventing damage from desiccation. So all those colorful changes happen before the leaves fall off, not to survive winter, but so the tree can survive winter by conserving resources when things get tough. Make sense?
Okay, so my next question from you is Maya. Hello.
Yes, this is Maya.
Okay, so do every green trees change color? Why or why not? Please give me answer on this topic. So let's start your answer, Maya. And
You're asking if AL green trees change color, and the short answer is no, they don't. But the longer story is more interesting. The trees that give us that dramatic fall display, the reds, oranges, yellows, those are primarily deciduous trees, which means they lose their leaves seasonally. Maples, oaks, beeches, those are the trees that put on that show. But then you've got evergreen trees, pines, spruces, firs, cedars, and those trees don't typically change color and drop their leaves. They keep their needles all year, which helps them photosynthesize whenever conditions are right. They can still slow down photosynthesis during winter, but they don't need to shut down the process as drastically as deciduous trees. It's not that evergreen trees don't have chlorophyll, they do, but they've evolved ways to protect their needles from the cold and drying out. They have special coatings and antifreeze like compounds in their needles that keep them going. So it's not about all trees changing, it's about two different strategies for dealing with winter. Some trees ditch their leaves to save energy and protect themselves from damage, while others keep their leaves and find ways to adapt. Does that make sense why some stay green through winter and others don't?
okay, so Maya, my next question from you is why are fall colors brighter in some years? Please give me answer on this topic. So let's start your answer.
I think you meant fall colors are brighter. Did I understand that right? If so, I can answer that. The brightness of fall colors depends on the right combination of weather conditions throughout the year. Here's what needs to happen for really spectacular fall colors. First, a season with enough moisture. The trees need enough water to photosynthesize efficiently throughout the growing season to build up sugar reserves. Next, you need sunny days and cool but not freezing nights in the fall. Cool nights help trap sugars in the leaves, which leads to those vibrant red pigments. Sunny days increase sugar production overall. If you get warm temperatures in the fall, the sugars move out of the leaves and you lose those red colors. But if you have a drought year or lots of warm fall weather, the color changes can be less intense because of that moisture and sugar balance. Also, a mild winter without any sudden heavy frosts will help hold on to the leaves longer so we can actually enjoy the show. It's a pretty delicate balance, too much of one thing or not enough of another, and you get dull colors rather than spectacular displays. It also really varies by location and species. Some years oaks might be especially vibrant, while other years maples really shine. So there's a lot of local variation too.
Okay, so my next question from you is how does climate change affect fall leaf colors? So let's start your answer, Maya.
I think you're asking how sunlight affects leaf colors, right? The intensity and quality of sunlight throughout the year significantly impact the vibrant autumn colors we see. Essentially, leaves need sunlight for photosynthesis during the growing season, which builds up sugar reserves in the leaf. But as the days grow shorter in fall, less sunlight signals the tree to prepare for winter by reducing chlorophyll and recovering vital resources. This reveals colors already present. Strong sunlight during clear autumn days helps trap sugars inside the leaves, which enhances the creation of the vivid red colors. Basically, sunlight plays two roles here. Initially helping produce sugars during the growing season, and then impacting the colors when chlorophyll breaks down. Are you still there? It sounds like we might have had a bit of a connection. Did you want to keep talking?
Okay, so Maya, my next question from you is why do leaves turn brown and before falling? Are fall colors different
That's a
around the
great
world?
question.
So
You're
please answer.
absolutely. Fall colors are totally different around the world. In North America, especially New England and the eastern US, you get that iconic mix of red maples, golden birches, and orange oak. Europe has more moderate displays. Beech trees tend to turn golden bronze, while oaks go reddish brown. It's less dramatic than New England. East Asia, Japan, and Korea have stunning displays with lots of crimson maples, vibrant yellows from ginkgo trees, and reds from Japanese maples. The weather plays a huge role too. Sunny autumns make for bright colors, while wet, cloudy ones might be more muted. Australia actually experiences fall colors in autumn, but trees like their native eucalypts turn bronzes and browns instead of fiery reds and yellows. Places in tropical zones don't have those long fall color shifts since there isn't the same big shift in seasons or decline of sunlight. So, where completely shapes what colors you see on fall leaves.
That's really great, Maya. So my next question from you is why do some countries have stronger fall colors? Please give me answer on this question. So
Good question. The reason some countries have much stronger fall colors comes down to things. First, climate. Regions with four distinct seasons, where there's a clear shift from warm, sunny summers to cold winters and have more dramatic changes. The temperature swings help trees produce those vibrant reds and oranges because they trap sugar inside leaves, as we've discussed. Next, the type of trees. With a lot of maples, oaks, and beeches that produce those bright pigments, have more showy displays. The third factor is soil composition. Nutrient-rich soils tend to grow healthier trees with stronger pigment production. For example, New England has really good soil quality. The combination of these factors means regions like Eastern North America and parts of East Asia get these spectacular fall color displays, while more tropical or arid regions might see less dramatic changes. Still with me, or did we finish up with the questions for today?
that's really great answer, Maya. So how long does the color changing process take, and can humans predict peak fall colors? So let's start your answer, Maya.
Good question. The whole color changing process actually takes several weeks, not just a day or two. It starts with the days getting shorter in late summer, which starts signaling the trees to slow down photosynthesis. The actual color change, when you start seeing yellows and reds emerge, usually happens over about 4 to 6 weeks in the fall. Timing of that varies depending on location and the type of tree, though. As for, yes, people can. There are entire websites and maps now dedicated to forecasting fall foliage. Scientists look at things like temperature, rainfall patterns, sunlight hours, and tree species to make predictions. Some years get predictions wrong due to sudden weather changes, but forecasters are getting better at this. Peak fall colors are notoriously hard to predict and shift from year to year.
Okay, so viewer, this was our Maya. I hope you like it. I met with a new Maya next topic. Thank you, Allah. Pakistan.